Okay gang, we're gonna stick with the chain rule, but in this video I'm going to use it with the trig. Okay, so you recall the derivatives of the trig, but this time the trig has an inner layer in it. Okay, so when the trig has an inner layer, it's a composite. So that's why if you notice, these trig derivatives look different. The sine is the outer layer, the u is the inner layer. Inner layer function, there's something inside of u, right? It's not a basic sine function. So the derivative is out e times in e. The trig is the outer layer because the angle or the function is inside of the trig, goes into the trig. So this is all the same concept, out e times in e, out e times in e, derivative of the out e times derivative of the in e, derivative of the out e times derivative of the in. It's the same concept. So notice, just to give you a quick example, earlier in 3.2, when we were just doing the derivatives, I've just shown you guys the rules, right? That's a basic trig. So what I mean by a composite trig is that you stick something in the trig. You stick a function inside the trig. Like instead of it being sine of x, it's now sine of 5x plus 1 because you've shoved a function in where the x used to be. And then that's what these rules are. Then you have to do out e times in e. So then that becomes the derivative. The outer layer is the sine, the inner layer is the 5x plus 1. And that's the part where you have to catch, like who's the outside, who's the inside, because if you don't catch that correctly, it screws up the derivative. So again, in this case, the sine's the outside, the 5x plus 1's the inside. So it's the outside, keeping the inside the same, outside keeping the inside the same. I'm just going to use this to help people with their eyeballs on how to look at this. Okay, this is the derivative of the outside. I'm going to times it by the derivative of the inside. Out e times in e. Out e times in e. We took the derivative of the sine first, kept the inside the same, then we took the derivative of the inside. And then you would make it look pretty. Just again, another reminder here, it's really important that you never put anything inside the trig without using an identity. This will never change. You have to use an identity to change this. This 5 will never go in here. Remember, this is inside of it, like our brain is inside our skull. We can't just magically shove a 5 in there because we feel like it, right? There's a wall around our brain. So this can't be shoved in there. This is inside the cosine. Like this would be like our brain, this would be like our skull. This is in this. So you can't just randomly put this with your brain. If you put this with your brain, then you have a hole in your brain. You don't want to have a big hole in your brain, right? You want to make sure your brain's in the skull, right? It's this kind of idea. You can't just shove something into it. It's got like a covering on it. Okay, gang, so that's the idea. So anytime it's not just a plain x in the function, it's the chain rule. See, this is just not a plain x. This isn't a plain x. So these become more complicated. So let's try this. This is the outside. This is the inside. I'm probably going to use brackets because I think it's easier for you to see it. So I do the outside first. Outside of this is the cosine. The derivative is the cosine. Oh, that's an x, not a pi. Alright, that's the derivative of the sine, which is the outer layer. Now I'm going to do the derivative of 3x over 2, which will be 3 over 2. And now I'm just going to make it look pretty. Alright gang, that's the answer to this one. Let's try another one. Now, sometimes people can't see correctly what this is, so I'm going to start by rewriting this. This is not the derivative. This is just another way to look at this because I want to make sure you see the problem correctly. This is saying we have 3 cosines. All right, now this is also way more complicated too than what I was just showing you here because notice now this has 3 layers. 3 layers. The outermost layer is the 3. The innermost layer is the The outermost layer is the 3. The middle layer is the cosine, and the innermost layer is the pi t. Every time I teach this section, I feel like I'm talking about some kind of Tootsie Roll pop, and the owl comes up in my brain. This is okay. You get to the innermost layer. There must have been something in that commercial. All right. So the outermost layer is a 3, the middle layer, and the inside of the Tootsie Pop is a pi t. Okay, that's the innermost layer. Now watch how we do this. You can only do one layer at a time, so be real careful when you do this. We're going to do the 3 first. So the 3 comes down in front. I'll put each layer in a bracket to help you. The 3 comes down in front, multiplies by the 5. So it's 15. The 3 is going to become a 2. I'm going to write it in this form versus this form, but you can keep it in this form if your brain wants that. So the 3 becomes a 2. And so that's the first layer where we've altered this. Again, if you want to write it this way, you've changed this to a 2, you've made this a 15, and you've put that in the box. Now this is the tricky part. When you've done a layer, your brain has to make it disappear. So like once I've done this layer, in my brain, I've cooked that piece. It's done. It's done its thing. It's gone. So in my head now, I'm just looking at this. So now I'm just working on this guy. You never carry upper layers, you only carry lower layers. Like you never carry outer layers, you only carry inside layers forward. All right, now the drill of cosine is negative sine. So then this piece is negative sine pi t. Okay, and then once I've done the cosine, it's like that guy's done. I've done that layer. If you're Tootsie Pop, that layer's gone, right? You've eaten it. It's not coming back. Well, hopefully it's not coming back. And then now you're just left with this guy, the Tootsie Center. Oh, this is this is torture for you guys. I'm enjoying it too much, torturing you. Okay, so then the derivative of the pi t, this is just pi. Right? And then that's it. You've got it. Let's just make it look pretty. So y prime. Now, out front you've got a 15, a negative, and a pi. So the nicest way to write that is negative 15 pi. Right? These are all multipliers that are out in front. And then however you want to write this, you can put the cosine first or the sine first. Okay, and then that's the final answer. Okay, I think I'm going to break this up because I still have 2 more to go. I don't want to make this video super long. So I'll pick up the trig again in the next video. I'll catch you, gang. Bye-bye.